we're going to go ahead and do a factor tree on the 98. Even 2 times 49. And then 49 is a perfect square. We might recognize that already. We could just recognize that right now because we're doing square roots, right? And so this is a 7. 7 root 2. So for the square root of 98, so we're going to do this in pieces so that you can see the work, is 7 times the square root of 2. Okay, because remember there were 2 7s here? 7 times 7, group of 2 7s, 1 comes out here, right? And then this extra 2 goes there. Okay, good. All right. Now we got to do the variables. We're going to do them the same way. X cubed. Okay, so again, 3 x's, right? We're looking for groups of 2 because we are doing a square root. 1 group of 2, okay? 1 group of 2. So, and 1 singleton. So when I take the square root of x cubed, I'm going to write 1x goes outside, and then I have the single x inside. All right, so from these 2 x's, this 1x, and this little x stays in there. Okay, y to the 5. Square root of y to the 5. Now I have 5 y's, right? Groups of 2. All right, so for each group of 2, 1 y goes outside. Square root of y squared is y. So I have 1 y here times another y there, y squared, and a single y from this guy, right? So I know I'm talking slow, but I want you guys to get this. Multiply these outer terms, right? These, so 7x y squared. Then put your radical. Don't forget the index, but since it's a square root, you don't need to write it. And then we have 2 times x times y. So 2x y. Okay, we've got that negative sign outside, so don't miss that when you go to do your homework. That means our answer has to be negative, okay? And we're going to do the factor tree on 150. So let's see. So 15 times 10, right? Yeah, we'll start there. Okay. And then 3 times 5 here. And then we have 5 times 2 there. Okay, so there's all the prime factors of 150. We're looking for groups of 2. Index is 2. We're looking for 2 5s. So here they are, 2 5s. So 1 5 will come outside with that negative sign. And this 3 times 2 will stay in the radical, multiplied as a 6. So we're going to build this. So here's what we got so far. Negative 5, leave some room. We're going to put some letters there. Square root, and inside the square root we have 3 times 2, 6. Okay, square root of x to the 4th. Oh my goodness. This is kind of cool because, right? How many groups of 2 x's can we make when there's 4 x's? 2 groups, right? So, and just so you visualize it, 4 x's, we're making 2 groups. Square root of each of these gives us an x to come out here with the 5. We have 2 of them. Multiply those together. X squared. That's a 2. Okay, y7. Okay, so now this is, we have odd numbers of y's here, right? But how many groups of 2 y's can we make? If you said 3, you are right? Because that'll take care of the first 6 y's. I can make 3 groups of 2 y's, right? And then I'm going to have this single y by itself. So out of each of these groups, I'm going to take a y out here with the x squared, multiply. So y times y times y cubed, put a 3. Sorry, we need more room. Okay, and then this little y is here with the 6 because he's left over, right? Left over. Okay, z9. Z9, that now there's 9. How many groups of 2 z's can we make? Did you say 4, right? Did you say 4? Okay, if you said 4, you're right, because that'll take care of the 8 z's, right? 1, 2, 3, 4. So z to the 4 comes out here. Oh my gosh, that's bad writing. And this little extra z stays in here. Okay, let me rewrite that last. Negative 5 x squared y cubed, right? There were 3 groups of y, 4 groups of z, then the radical, and left over I had a 6 from here, a y, and a z. 6y z. Perfect. Let's go to the next one. Are you getting the hang of this? Here comes the next one. Cube root of 120. Cube root, first of all. Did you notice that? Cube root of 120, x to the 8th, y to the 10th, z to the 12th. So we're looking for groups of 3. Groups of 3. All right, but let's do a factor tree. 120. That's 12 times 10. And then 12 is 3 times 4, right? And 4 is 2 times 2. And then 10 is 2 times 5. We're looking for groups of 3. So do you see a group of 3? Do you see 3 2s? Here's 3 2s. Right here, 3 2s. So 1 2 is outside the cube group, right? And what's left over? 3 times 5, 15. Leave some room. Don't forget the index here. Put the little 3. 3 times 5 is 15. Okay. X to the 8th. 8 x's. We need groups of 3. How many groups of 3 can we make with the 8 x's? Well, there's 1. There's 2. That takes care of 6 x's. And now I'm going to have 2 leftovers, right? 1, 2. So out here with the 2 joins an x squared. These get multiplied, right? Inside, left over with the 15 is an x squared, because these get multiplied. Y 10. How many groups of 3 y's can we make? Did you say 3? That'll take care of 9 of those y's, right? There's one group, there's the second group, there's the third group, and there's a leftover. 3 means y cubed out here, 1 left over in the radical. Okay, 12 z's. How many groups of 3 z's can we make? Did you say 4? Put a z to the 4 out here. Nothing left over, right? We used up all 12 z's. Okay, so this is your answer. OMG.